Quadratic transformations. So if we look at the equation, this is the way that your equations will be written for transformations. The different letters do different things to the graph. So we have our A, we have our H, and we have our K. So depending on where the graph is moving, those numbers will be different. So whenever the A is different, the A may make the graph flip. That's if it's negative. If the A number is, if A is bigger than 1, it will stretch the graph. Which will make it look more narrow. On the other hand, if A is less than 1, it will compress the graph, which will make it look more wide. The H is inside the parentheses with the X, and remember the X is our left and right axis, so the H makes the graph move left and right. Keep in mind that this is negative H, so that means it moves the opposite direction. A positive H will move to the left, and a negative H will move to the right. And then we have our K, which is outside the parentheses by itself. The K moves the graph up and down. So a positive K moves up, and a negative K moves down. So let's look at our first equation. The graph of f of x squared was transformed to create the graph g of x equals x minus 7.5 squared, which describes this transformation. So you also can graph these two in your calculator. So if you want to graph those in your calculator, you can, or we can look back up at our notes, and whenever it's inside the parentheses with the x, that moves left or right. And then remember, we said it's opposite, so if it's negative 7.5, that actually moves to the right, 7.5 units. This question says quadratic functions q and w are graphed on the same coordinate grid. The vertex of graph q is 18 units below the vertex of graph w. Which pair of functions could have been used to create the graphs of q and w? So again, you can graph these in your calculator, or using our notes from above, it says that whenever it moves up or down, that's the k on the outside of the graph. So if we have f of x equals x squared, then to move up and down, it would be outside the parentheses minus 18. Okay. On the next one, we have the graph of f of x squared, and then we have 2 times f of x, and remember, f of x was x squared. So if you wanted to graph this one, you can just put 2x squared in the graph, or in x squared, and you would see what it does. At the top, we said if we change this number before the x squared, then it makes it more narrow or more wide, and since 2 is bigger than 1, it would make it more narrow. F moves up, so that cannot be the answer. H moved right, that can't be the correct answer. On G, the first graph was more narrow than the second graph, so this one actually got wider. And on J, it got more narrow. So that's called a stretch. Our next question, function p is in the form y equals ax squared plus c. If the values of a and c are both less than 0, which could represent p? Now remember, if a is less than 0, that means it's a negative, so our graph would have to flip. That means we can eliminate g because that one is right side up. If c is a negative, that means it moves down. So h moves down from the original function, j stayed right at the same, and f went up. So h must be our answer. Last one, the graph of f of x equals x squared is shown on the grid. Which statement about the relationship between f and the graph of g of x equals 7x squared is true? So remember, if this number is before the x squared, that makes it more narrow or more wide, so we can go ahead and cross off h and j. You can also graph 7x squared and see how it would look on this graph. So if you were to graph it, you will notice that this point is about here and here. So our graph got more narrow, which is letter F.